Okay, this is the second video for 5.4. I was looking through these and I'm noticing there's some typo errors, not on my key, but on a blank copy. So forgive me, but I'm going to go over them with you now. So we just did some examples that actually covered these properties of definite integral. So if f is defined at x of a, then when you go from a to a of a function, there's no area there. We just saw that before. If you're going from b to a, you flip-flop them. Normally a is the smaller and b is the larger. Then you would take out a negative. And we noticed that in the previous video. Some additive interval property here. So just so you notice, this is where one of the first things is wrong. This should be a, and this should be b. You can actually separate two of them with a different number in between a and b. And you can go from A to C, C to B. Just notice that this bottom number is A, and this top number is B, and then there's a number in between, and then you can add them. Same thing here. Sorry about my copy, but that should be an A and a B. If you have some constant K, you can actually take that K outside and then integrate what's inside and then multiply K back. If you have just a constant, then your area would be that constant times b minus a. Because remember, we're talking about rectangles here. And then, again, one more correction here. Sorry about that. Need to remember to make the copy correct. If you're adding two functions, you can separate your integrals. Okay, so let's use these properties of integrals to evaluate each of the following. So what they've done, I'm kind of zoom in here, is they've given you three different functions and they told you what the area is. From a to b, it's 8. From a to b of g of x, it's negative 3. And then from a to b of h of x, it's 5 over 2. Okay, so let's answer these first question. What would be the integral then from b to a of g of x? Well, that goes along with flipping. Okay, that's a flipping right there. So what would be the integral? You would actually rewrite a as negative and then switch these two, a to b, of g of x dx. So this would be the negative, and this right here is right there. We have that same thing as negative 3. So it would be 3. Okay, let's do another one. The integral from a to b of 2 times f of x. Okay, well that 2 I can actually put in front of the integral. Okay, and then the integral of a to b of f of x, we have that right here. It's 8. So it's just 2 times 8, which is 16. All right, what about C? What if I'm integrating just a number? Then you would do, according to the property number 5 right here, you would take that scalar and then multiply it by b minus a. So 5 times b minus a. Since we don't know what b minus a is right now, like it could be a 1 and a 5, we're just going to leave it as 5 times b minus a. Okay, part D, I'm adding two different integrals together. So I would take the integral of each, the integral from a to b of g of x dx, and the integral from a to b of 5 would be 5 times b minus a, plus the integral from a to b of g of x, well, that's up here. It's negative 3. And you can just leave your answer like that. 5 times b minus a, I should say minus 3. All right, two more here. E, the integral from a to b of f of x minus h of x, you can actually separate them. Minus the integral from a to b of h of x dx. Please notice my notation. We're going to talk more about this. Put this dx right there. The integral from a to b of f of x dx, that's right up here. That is 8. minus the h of x1 is 5 over 2. And I believe it's 11 over 2. All right, last but not least, the integral from a to 4 of h of x plus the integral of 4 to b of h of x. Interesting. These are the same number, a and b. You can actually combine this to be 1, going from a to b of h of x dx. And we have that, and that is 5/2. So pretty easy to use the properties. Definitely going to want to write them down and know them. All right, let's find the following. If the integral from 1 to 5 of 3 times f of x plus 4 dx equals 34, find the integral from 1 to 5 of f of x dx. Ooh, interesting. Okay, so let's use our properties and kind of separate this and find out what's going on. So this 3, well, actually, let me start with the plus. Let me separate this into the integral from 1 to 5 of 3f of x dx plus the integral from 1 to 5 of 4 dx. And we know it equals 34. This, we can take this 3 on the outside. And this one, we know that this 4 is a constant, so the property says you would just do 4 times 5 minus 1. So then, let's see what we got here. 3 times the integral of 1 to 5 of f of x dx. 4 times 4 is 16, and this equals 34. Let's bring 16 over. So 3 times the integral from 1 to 5 of f of x dx must equal then 18, right? Subtracting the 16. Let's divide out the 3, and look at there. It must be 6. Pretty cool. All right, last but not least, let's just talk about even and odd functions. So consider the following. If you have an even function from 0 to 3, f of x dx equals 8, then what is the value of negative 3 to 3 of f of x dx? So your most common, if you don't remember what even is, it means it flips over the y. Flips over the y, okay? So let's just take, I don't know, like good old parabola. That flips over the y, okay? And if I'm telling you that this side, let's say this is negative 3 and this is 3, and I'm telling you according to this part right here that this area right there is equal to 8, then what do you logically think this side is going to be? Don't you think it's also going to be 8? Because it's even, symmetrical? And actually, that's what happens with an even function. If you goes from negative 3 to 3 for an even function of f of x dx, then whatever the half of it is, you just double it. It's 16. Now, odd function, a little bit different there. Odd, remember it flips over the origin, odd origin. Okay, so let's take good old the cubic one. So I love the cubic one. Okay, so if we're going again from negative 3 to 3, and I'm telling you that from 0 to 3, this is 8, what logically can you assume this is? It's not 8. It's what? It's negative 8, right? It's under. So then what would you tell me? What would this derivative be? Sorry, what would this antiderivative be equal to? This would be equal to, from negative 3 to 3 of the function, 0. Okay? You are going to try your homework tonight and then come back tomorrow and watch one more video. We're going to, some cases we need to use geometry, and that's what we're going to work on tomorrow. Bye-bye.